So now what will be the velocity profile? How will the velocity actually vary? So we know that in case of pure rolling, we can consider this as pure translation. So if it is pure translation, then omega has to be equal to 0. I can say that all this value of v, all these points are moving with v velocity. Together they're all moving, right? So what will be the expression of kinetic energy? Well, I know the total kinetic energy is rotational kinetic energy plus translational kinetic energy. In this case, do you have any rotational kinetic energy? Think. Do you have any rotational kinetic energy? No, sir. Why? Because I am considering omega to be equal to 0. I am considering a pure translational motion. So what will be the kinetic energy? That's going to be equal to kinetic energy translational, that will be equal to half mv squared. Correct? Half mv squared. Very simple. All right. So because we have velocity of each of the particle as velocity of center of mass, since we are considering only translational motion, we'll have only translational kinetic energy, and that is equal to half mv squared. What about when we consider pure rotational motion? Well, for pure rotational motion, as you know, that this point is going to have v is equal to r omega, this will be minus r omega, right? And this point again, you know, in this direction, something like this. But if I talk about kinetic energy, it has to do nothing with direction, it's a scalar quantity. In this case, it is just going to have rotational kinetic energy, correct? Right? So rotational kinetic energy, that is K rotational, Ke rotational, is going to be equal to half I omega square, where I is the moment of inertia of this one. Now here comes one interesting thing. You can also write this I in terms of radius of gyration. In terms of radius of gyration, because you might not know every time what is given there, like for a ring, for a disc and all that. So I can always equate I is equal to mk square, correct? Right? So what I can write, if I can rewrite this ke net is equal to half, instead of I can write mk square omega square. That's also totally fine. Okay. And if it is a case of pure rolling, we have got one more relation. What is that relation? V is equal to r times of omega. So you can also write omega square is equal to r square. Sorry, we can also write omega square is equal to v square by r square. You can also rewrite this expression in that sense. So you have got kinetic energy rotational is equal to half m k square, and omega square can be written as v square by r square. So you see, you have expressed rotational kinetic energy in some term of linear kinetic energy, and that's the beauty of this, right? That is the beauty of it. So what we can write, kinetic energy rotational is equal to, you have half mv square times k square by r square. What is half mv square? Half mv square is nothing but kinetic energy linear or translational. Kinetic energy translation. So you see, these are the relation that they will give you. They will give you radius of gyration. They'll give you the radius of this V, okay? And they'll give you linear kinetic energy. And they will tell you what is the value of rotational kinetic energy in this case. Okay, this is how they trap you. This is how they trap and try to make it conceptually difficult. But once this understanding is clear, once you know the situation, how you can do it, because for pure rolling, I can write V is equal to R omega, and I can write it like this. Very simple. Okay, so that's about kinetic energy. All right, you must have noted it down, I'm sure. So once you get this value, you know that you can also express the rotational kinetic energy in terms of linear kinetic energy. So when you write total kinetic energy, it will be linear plus rotational, and you know that you can take the linear part common and then you'll get a simplified expression. That is also true. Okay, fine. Now talking about the net motion or the net velocity profile, because velocity profile is what we have been discussing. So you see, this is because of pure translation and this is because of pure rotation. So if I talk about this point and this point, let us say, and this point, all right, let me mark it as A, B and C, and let me mark over here also A, B and C. Let me mark here also A, B and C. Okay, point on the periphery. how the velocity profile is going to look like. First of all, because of translation, point A has velocity in this direction. Okay. Because of rotation, point A has velocity in this direction. Okay. Clear with this? Then, if I talk about how much, this is V, this is R omega. If I talk about point B has a velocity V in this direction. And point B, because of rotation, has got no velocity at all. If I talk about point C has got a velocity in this direction, V, and that is because of translation, and because of rotation, it has also got one more value, that is R omega. And now we know that if it is a case of pure rolling, we can write V is equal to R omega. So this R omega also becomes equal to V, this also becomes equal to V. So net velocity of point C becomes equal to 2 times of V. Correct? This is V and this becomes equal to net velocity of this point, that is VA becomes equal to 0. Condition of pure rolling, right? Which means if I talk about the velocity profile, then what happens? How the velocity actually is varying, and this is very interesting. At this point, velocity is equal to 0. At point B, that is the center, velocity is equal to V, velocity of B. So this was point A, this was point B, and this was point C. And at point C, velocity is equal to 2 times of V. Correct? Let's draw a vector. So this is how the velocity is varying. This is 2V. You see a linear distribution. This is V and this is 0. This is how the velocity profile is going to look like. For all others, it will be something like this. This is how the variation of the velocity takes place. So the topmost point has got a velocity of 2V, the bottommost point has got a velocity of 0, and the point of center of mass is moving with velocity of V. Simple, easy. Did you understand this velocity profile? Yes. Write it down, draw it yourself. So for a pure rolling condition, you have got the lowermost point, the velocity is equal to 0. Okay. And at the center, the COM will be moving with VV, which is equal to R omega. And this will be moving with plus 2 R omega or 2 times of V, whichever you want to call it, because they are equal. Okay. All right. So as we know that when it is a case of pure rolling, at the point of contact, if we are talking in terms of ground, that would be the general case. There is any special case, I'll tell you. So if we are talking just about the ground, then we know that velocity of point of contact is equal to 0, or relative velocity has always equal to 0 if it is a condition of pure rolling. Fine. And the velocity of center of mass can be written as R times of omega, and the velocity of the topmost point is equal to 2 times of velocity of center of mass, or 2 times of R omega. All right, this is clear, very easy, right? Shall we go ahead then? So now that we have calculated separately the value of rotational kinetic energy and translational kinetic energy, let's calculate the total kinetic energy. So you know that kinetic energy total is going to be equal to kinetic energy translational plus kinetic energy rotational. We know kinetic energy translational is equal to half mv square, right? Plus kinetic energy rotational is equal to half I omega square. And as I told you that I, you can write it as mk squared, right? So I can be written as I can be written as mk square, right? So I can write it as half mv square plus half, instead of I can write mk square. And we know that V is equal to R omega for pure rolling. So omega square can be written as V square divided by R square. Okay. So if I rearrange this, I get half mv square plus half mv square times we have k square by R square. If I take half mv square as common, what do I get? Come on, do it fast. There's no time now. Come on. Okay. So if you take half mv square, I've already done all this. I'm just recapitulating everything. So half mv square, if you take it as common, you end up with 1 plus k square by R square.